recording, and hopefully that behaves. I'll start with our Discord poll of how everyone is. So, how are people this week? And I'll also get up a couple things. There's a bit of admin-y stuff to go over before we jump right into today's topic. And today's topic will be CAD and 3D modeling in Fusion 360. So hopefully that will be new to a decent chunk of you, and will be helpful. And additionally, we have today, even though they can't be in the session itself because they're working on assignments, I think, Luke and Bhumika, who are in the Discord, in the Bootcamp voice channel. So they will be there to answer questions if you have them as you're going along, or if you're trying to follow along like at the same time and you're having a particular issue, you can feel free to ask me or them as well if there are several questions that I can't handle all at the same time. But I think we should be pretty alright. Cool. Awesome. So with that being said, and I can relate to the shrugs on how people are doing this week. It's been a shrug-worthy semester, but that is all right. We'll all survive eventually. Wonderful. Cool. In that case, I think we will start with decisions from high management. By high management, of course, I mean just the committee. We're going to try and start taking attendance for these things like when we can. And it's not to like hold anyone to attendance because obviously they're all optional. It's a society thing. But it is good to keep track of the people who show up to these sorts of things so that, say, if we're collaborating with another society and we want to do like, say, some collaborative event between our bootcamp sessions and something like the AI Society. So if we want to do some machine learning, artificial intelligence session together. It's good to be able to show them that we actually have people showing up to things. So, for that, I have a short little form for people to fill out. And by short form, I mean you literally just put in your name, and that should be all you need to do. So, that is there. And I'll also put it in the Discord for people to fill out. And I'll give everyone a second to do that. And get another form, right? Wonderful. Okay, so once everyone is done filling in the little attendance thing, which is just asking your name, doesn't have to be, full name or anything, just whatever you want to be called, or known as long as it's like consistent, we can keep track of it from week to week. The other thing is that we are nearing the end of our bootcamp section of the semester. We're trying to end, obviously, I actually don't know when our last session is, but after today, there are 3 more weeks. And the last 2 of those are pretty flexible. So next week, we'll probably continue on with a bit more Fusion and some advanced things, and we'll also talk specifically about considerations to keep in mind when you're 3D printing things. And we'll also take a look at some 3D printing software and how that and Fusion play together. But after that, it's a bit open. Originally, it was in the plans to try and shuffle everyone down to the iForge, so we could do like some hands-on working with tools, but it seems like that will be logistically complex with the COVID situation, so that might change a little bit. So I have, for everyone, a form, which I think I already copied the link for. Let's see, that's a different link. That looks like a different link, which is about plans for the end of the semester. So the first question on there asks what sort of thing you'd like to see the week after next. So that is the after we finish our Fusion and 3D printing section. And that's just, would you like it to be a review session? Would it be good if it was some totally new topic? Would you want it to be some Q&A or maybe some practice session where I come up with exercises and we all do some practice together? So it asks some questions about that. If you have any specific ideas, it'd be lovely to hear from you all what you want to do, because I'm also quite conscious of the fact that as we do reach the end of the semester, I'm sure plenty of you have deadlines and other time-consuming things to work on. So I don't want to do or take up too much time. And then additionally, kind of as like a Bionics thing in general, all of the sub-teams are thinking about working together on some sort of showcase at the end of the year. This would be an opportunity for, if any of you have anything that you worked on during Bootcamp, or if you've been in the other sub-teams otherwise, just if there's anything you've worked on that you want to show off to some people, that could be a space for you to do so. And additionally, we're going to try and get the sub-teams themselves to show off in some sort of presentable form the progress that they've made over the semester, so that way maybe those of you who haven't yet branched out to the other sub-teams can get an idea of the sort of work they're doing, and you can pick a new home if you want to continue on and do that. So yes, that is what that form is all about. It's asking if you have any interest in that showcase at the end, and also what you'd like to do in week 9, which is the week, well, okay, they don't quite line up with university weeks, do they? But the week after next week. That's the session that's kind of flexible at the moment. Awesome. So obviously, if you're thinking of ideas, you don't have to fill in the whole thing now, but it would be excellent at some point to have people's ideas there. But without further ado, I think we can head on to our CAD session. And I've also, because I've actually prepared slightly for this session, I have the feedback form prepared in advance, so I'll send that before everyone takes off at the end of the thing. Because it seems like, depending on where I post the feedback form, the number of responses definitely varies. So maybe I'll get it to you all in person today. Wonderful. Alright, well, I suppose then, without further ado, we'll move on to Fusion. So I'll double check I'm recording. Should be. Yep, fantastic. Alright, so today's topic is CAD, which stands for Computer-Aided Design, and it's pretty vague because it can be a whole bunch of different things. Fusion can do a lot of different jobs for us as well. So the bit that we'll be working with most is the design workspace. So first of all, I guess we'll open up Fusion so everyone can, we'll go from the beginning. If I can close Fusion. Yeah, there we are. Hello, hey, that's a sneak peek of what we'll be doing later. And my desktop is a disaster. And Fusion is there. Wonderful. Right, so if you open Fusion on your computer, whether you've got that installed on Mac or Windows, don't worry if you don't have it installed, you can still follow along. Well, not follow along, but you can still watch. If you do have it, you can follow along. But it launches just like this eventually, takes a little while. I'll also ask, now that we have a larger audience of people, is this all legible, or should I make this larger for you all to see? Is this too small, the interface and everything? What do people think about the size of the screen? Is the screen big enough? Okay, cool. So I mean, alright, we'll get okay. Seems like for the majority of people it is pretty alright. That is good. We have a one not sure, which is fair. I'll be making a good point of reading out and saying verbally also what I'm doing so that we don't need to rely on this text too terribly much. And if I get bad at that, just scold me for it, and I will improve on that for you, or I'll switch back to saying things verbally if I ever forget. Excellent. Yeah, so as I was saying before, this is kind of what Fusion will look like. You might have in your thing as well a data panel is what they call it. So here's where you put all like your projects or people you're working with and things. So for example, random things that I've worked on. I've 3D printed a phone stand and a ski for a goose. That's exciting. Another couple of things I've done, so you might see something actually more like this, which is the home. You'll have a default project somewhere. I've also worked on designing a bioreactor at one point. So there's an assembly somewhere in here. Yeah, there we are. That shows a bunch of things that have gone together, form a little bioreactor model. But this over here kind of acts as your general place for storing your projects, for exploring them in Fusion. They call it the data panel, and you can hide it with that button or show it with that button again. So I'll probably keep it hidden for most of this because we don't need to fuss around with it too much. So go back to Home, Default Project, Bionics Bootcamp. There we are. And we'll close that. Excellent. We'll have a new blank slate. So, I think the plan for today is going to be, I will try and introduce you to the general idea of designing things in 3 dimensions and how you can do that with Fusion 360 in particular. And then there's a set of exercises, so challenge problems to work through designing. So, oh, this is not indeed Linux. I'm going to struggle with that today. Goodness, there we are. So these are some exercises of varying complexities that we'll be going through. So we'll start with the simplest ones, and we'll move our way up probably at least until this one, which is a decently complex part. And if we have time, we can start playing around with some more advanced ones, but we might get around to those in our next session because they involve some more advanced techniques in Fusion. But we'll start just by exploring a couple of the tools and the general idea behind parametric CAD is what it's called. Fusion has these menus up here when you're in the design workspace. They give you a bunch of really helpful tooltips, so if you go and you scroll over them, they'll tell you a little bit about each of these little tools, and they'll show sometimes a picture of what you can do with them, which is fantastic. With that being said, I think to be most effective when you're designing things in Fusion, it's nice to know the keyboard shortcuts for things. So when there's an easy shortcut available, you can see some things that have shortcuts, like extrude is E, hole is H, and things like that. When there are these easy shortcuts, or other tricks like when you right-click with your mouse, you get some context here. When there are tricks like that, I'll try and show those off, at least the ones that I know, because they're a faster way to work. But I'll try and be sure to show you both the visual and keyboard shortcut solutions to all the things that we come across. So, without further ado then, let's make our first shape in Fusion. So there's a number of ways to do this. You could either go into your Create panel here and pick some pre-existing solid, which is what this kind of section here is. So if we wanted a box, all we have to do is click on a box, and then click on a plane. So this is our origin. We have 3 axes and 3 faces to put it on. We can just click there, and then build ourselves a box, like that. And that's one way that we could go about doing things. But we'll probably, most of our time that we'll be working with Fusion, be working with things called sketches. And that's where we'll see the parametric nature of the CAD come about. And the parametric part means that you can specify different parameters. So actually, if you look at this little picture that they've given us here, even, if it pops back up. Yeah, sure, okay. So I can't point to it at the same time. But you can see in this sketch here below, where you have some lines, that they have different dimensions on it, and there are some symbols scattered about that mean different things. And we'll take a look at what those mean. Those are constraints. So if you know certain things about how you want your shape to look or your part to be, you can specify those, and it will ensure that those conditions are always met, and it gives you lots of flexibility. So I'll show you what that means practically. So when you're first starting, and you want to create a totally new sketch from nothing, you can go up here to the Create Sketch button, or as an alternative, you could show your origin, which you do by clicking this little eye sign here. If you show your origin, you can then click on a face to design. We'll design on this one because we'll keep our Z axis as up. We can click on that, and if we right click, you can see some options down here. One of them is Create Sketch, so we can do Create Sketch. Now, you can see that's changed our interface quite a bit here. On the side, we now have something called the Sketch Palette, which gives us a number of little options here. Our view cube here has stuck us in the top view, so we're looking directly at the plane that we're sketching on. Note that, and it might be different depending on your control setup, but you should be able to, if you have a mouse with a mouse wheel, like a scroll wheel, hold down Shift and then click your mouse button to orbit So this is like a looking around in 3D space kind of thing. The alternative to that, if you don't have a mouse with a middle scroll wheel, you can also go down here and click on this orbit option. And then you can just click anywhere on the screen or regular left click to do the exact same thing. So that's nice and convenient to have at your disposal. And you see as we do that, our view cube up here in the top right corner moves around, so you can see that. If you ever want to get back to an exact position, like we could try and look exactly down on this, but it's a bit difficult to get it exactly right, you can just click on the top view, snaps you back into the top view. These arrows here, that lets you rotate things around this way. So you can rotate things in 90-degree increments, and these little arrows on the side let you turn the view, I think, to the right side, then to the bottom, then to the left, then to the top again. So those just get you to this other side of the cube that's like hidden just past this way. And if you click on a corner, of course, you can see at an angle. That's a bit difficult to see, I'll admit, when there's nothing drawn. We'll come back to that once we have something actually in 3D space. Additionally, one last just like moving around control before we actually draw something. With your middle mouse button, if you've got one, if you just click and drag that without pressing shift, you get pan, which just moves the screen around like this. Of course, you can even see when I do that, it highlights the graphical equivalent, which is this pan option here. So you can click on that, and that lets you move things like left and right and up and down. Yeah, and those are the main controls. Scrolling like you would on a web page, just in and out, whether that's with a touchpad or an actual mouse, zooms you in and out of the model. And you can see as we zoom in, it gives us more and more grid points. But if we zoom out, there's obviously a point at which, it kind of cuts off our little grid. But cool, so that is how you navigate in general. For the people who have Fusion open, I imagine you've given that a bit of a go. I'll create a quick poll. Any questions about looking around in Fusion? And these are just things that'll become second nature eventually. Oh yeah, I realized I phrased that as a bit of a confusing thing. I said any questions about as opposed to Okay, fair enough. Well, if you do have questions, feel free to write them in either the Discord, which is where the polls are, or in the meeting chat. Okay, we have one person who might have a question, unless of course they've reacted with a positive because they don't have a question, which is my fault for making it confusing. That vote has since disappeared. Okay, yeah, my fault for making that a confusing question. I'll try and keep them positive answers in the future, instead of negative like that. Okay, awesome. Well, if there are no questions, and if there are questions, feel free to write them, and I'll get to them. We'll go back to our top view by clicking the top of our cube, so no matter where you are, you can just click on top. It gets you back to your top view. That's where we're sketching, and we'll draw something. So, say we want to draw that same box as before. There are a number of ways we can go about this. There are actually several types of rectangles you can draw. Of course, you see up here in your Create menu, you now have some different shapes. So one of them is a 2-point rectangle. We can click on that, draw out a rectangle here, and there's a rectangle that we have sketched. And I'll re-hide our origin so it's not in our way anymore. So there's one rectangle. Another way to create the exact same thing, and you can undo just with Control Z like you normally would. So I'll turn back off the origin. So you can undo with Control Z. Another way to do the exact same thing is you can press the R key on your keyboard, and you can see that changed me into this different mode here that just automatically sets me up to draw one of those 2-point rectangles. So I can press Escape to leave this mode. So Escape gets me out of that, and then from there I just press R and I'm back in a rectangle mode. I can draw more rectangles. I'll undo that. And finally, the most useful thing, I think, for your Fusion work is going to be pressing the S key. If you press the S key, it pops up this little menu here, this search menu, wherever your mouse is at. You see it has a couple of things that are pre-locked up here, like a 2-point rectangle. There's another type of rectangle called a center rectangle. But you can type on your keyboard anything you would like, and it will search all of these menus up here for you and return relevant results. So if I did S and then I typed rect, You can see we have rectangular patterns we can do. There's a center rectangle, a 3-point rectangle, or a 2-point rectangle. We can choose any of these. And you also see when I scroll over them, there is this little arrow here, and that would put it up in this toolbar. And if I want to move it out of the toolbar, I just press the X again. So you can put some shortcuts there. It's incredibly useful, this little S menu. You'll see me using that a bunch throughout this tutorial. So whenever this little menu pops up here, I'm pressing just the S key on the keyboard. And that works in both this sketch mode and also in the more in the non-sketch mode of this Fusion's design workbench. So very, very helpful shortcut, the S shortcut. Stellar. So I'll go on and press the S key, and I'll grab a center rectangle. I'll show you how that's different. So here, instead of clicking on like a corner of the rectangle, you're clicking where you want the center of the rectangle to be, and then you can click and drag it out. Then you see here that this rectangle, it has its center where I initially clicked, and then I just have to place the other point of it. As I do so, you can also see that there are some dimensions on either side of this rectangle that are changing. And you can also see that that one here on the left, well, on exactly the opposite side of wherever I put my mouse, so I can't really point to it, is highlighted. That means that you can directly type in there how large you would like that side to be. So if I wanted to make a 10 millimeter by 10 millimeter cube, so that's just a 1 centimeter cube, I could type 10, and you see that changes it there, and it also changes the size of the rectangle. If I press the Tab key, so the Tab key above caps lock probably, that moves you to the other dimension. Then you can just type the same. So you can type 10 again, or 20. You can type 10 again. And then from there, just hit Enter, or you can click with your mouse to finish the shape. So what we see here is a fully constrained sketch. So by fully constrained, you can tell that because, first of all, this shape is black. You'll notice that's different from if we just created a rectangle here with no dimensions. This one is blue. What the blue means is, if you just take your cursor, so if you press Escape and you just have your cursor, you can grab sides, you can move them, you can change it. It's not really a very defined, it's not constrained to only be one way. It can change. But it's good in your designs to lock things in so that they cannot be changed without changing these dimensions. That ensures, I guess, that no matter what future things you do down the line, it'll always be guaranteed that this side is 10 millimeters long. It'll always be guaranteed that this side is 10 millimeters long. And these constraints here are equal constraints. So that means that this side will always be equal to this side. You can see when I hover over one of them, it lights the other one up. And this side will always be equal to this side. And that's just something that defines this rectangle. That one there means perpendicular. We'll see a bit of that later. It looks like that little T shape. And that one means it's horizontal or vertical. So in this case, it's horizontal. And if I try and grab this, it's a black shape, so that means it's fully constrained. No matter where I grab and click on this rectangle, I can't move it around because the center is locked to the origin, and the sides are locked to be 10 long, and it's locked to be a rectangle. So you can see that gives me absolutely no room to mess about. Here, so let's go ahead and delete this shape. I can highlight it and press the Delete key on my keyboard to get rid of it. So here's our little square. If we want to make this three-dimensional, we can do a number of things. So we could first finish our sketch and then get back our 3D tools. So I'll show that real quick. So if we finish our sketch and then we have our 3D tools back, we can do either a press pull or an extrude, which I think is actually hiding under here. So yeah, there's an extrude. Either of those work, but press pull is very helpful, and that's under the Q shortcut, and you can actually do that from inside the sketch. So if we go back to our sketch, whoopsie daisy, yeah, back into our sketch, then from here I can just press the Q key on my keyboard, and you see this press pull thing's popped up. I can click on the bit that I want to press pull, which is this bit here, and then if you look at the side, you can see it's giving me the option to pull this up into 3 dimensions. And now we have a square there. You also see that it gives me another highlighted number. This is, again, the dimension we would like to pull it out this way. So since we're making a cube, I can just type in 10 and then press Enter, and then there we are. So now you can see here we have an entirely, or a complete cube. Look how fancy we got there. If, by the way, any of you are looking at this cube and thinking it looks a little bit strange to you, that might be because, by default, Fusion uses something called orthographic projection. That's basically a bunch of fancy mumbo-jumbo for if you have some shape, like this cube, and you copy it, and I'll paste it. I'm not sure if I'm actually allowed to do that. I've not actually done that before. So, okay. I will take this body here, copy it, paste it, and move that this way. So now we have... Oh no, what have I done? Oh, I canceled the move. That's my fault. So I need to click enter instead of escape here. That's fine. Cool. So if we have two squares, what orthographic projection does is it ensures no matter how far away they are, they always look the same size. So in our actual, like, human vision, when we look at things, the farther in the distance they are, the smaller they are. And that's just a matter of perspective, so there's plenty of reasons for that. So you see here, in orthographic projection, they always look the same size no matter what distance they are. This is nice for making mechanical parts, because you can just like overlap things, and you see wherever they overlap that, okay, they must be the same size. So that's helpful. Fusion also, however, lets you look at things in projection mode, which is how you might more naturally see it in like the real world. So you can do that up here by going to perspective mode. Sorry, that's what I meant to say. Perspective mode. And now you see this looks more like what you would expect in the real world, where the things in the distance are smaller, and the things up close are bigger. You can also see that the grid lines are more realistic as well. So it's useful occasionally to go into perspective mode just to see what things might look like a bit more in the real world. But the orthographic mode is very helpful for actually designing things. You also have that option in addition to up here. You can get to it down here, display settings, and visual style? Not quite visual style, camera. Back to perspective, or orthographic. So see here, now they're the same size again, which is very helpful. Although the visual illusion makes the distant one look a bit bigger. Interesting. But that is that, so I can get rid of that second one. Yep, that's fine, I don't mind. Stellar. And we'll go back to our front view. And zoom in a bit. And up here. So back to our cube. I'll ask real quick how people are feeling about all of that. So I'll create another poll. Not a pool, we're not going swimming. How are people feeling about sketches and extruding? This time it's a positive poll again, so if you're feeling good, you press the up one. Excellent. Sounds good. Does anyone have any questions about the orthographic projection stuff? I mean, that is far from like particularly important, but it's just kind of good to know if things look weird, that's why. Awesome. Cool. Seven ups there. That's pretty good. Awesome. If you do have questions, feel free to drop those in either chat. I've got them both up at the moment. But if you don't have any, we'll move on and look at some more complex shapes and things to build. Oh, yes. Okay, cool. Yes, I know what we'll do next. Awesome. Alright, I'll assume then things are pretty alright. If they aren't, let me know. But it's time, I think, to take a look at one of Fusion's coolest features, which is this timeline down here. So what this timeline lets you do is go backwards and forwards in history and take a look at all the different edits that you've made. So what you can do with this parametric modeling especially is go back in time and change something and see how that updates your model in the future. So this extrude is one feature. So this extrude is when we took our two-dimensional object and made it three-dimensional. So that just went 10 millimeters up, or a centimeter up. If we go back to before that, you can see we have nothing again. We just have, if we reveal it, so here is a project tree, I guess, or document tree. So you can expand all these things and see what's inside of them. So here's our origin. So if we turn that on, you can see here are all the different parts of the origin, the different planes, the point in the middle and everything. And you can press all these eyes to toggle their visibility on and off. So I'll hide all of the origin there and collapse it again. Under sketches, you have our first sketch that we drew. So if we're not seeing it, like we aren't now, we can click on it and now we can see our sketch again. but we can hide that as well. You can turn it on and off with that, which is very good to know. But if we wanted to edit one of these features in the past, we can go and double click on it. If we double click on it, you can see here we're back to our sketch view. So we've seen this before. What if, say, we wanted not a cube anymore, but we wanted a rectangular prism? Then we could go down to this constraint here that says, okay, this should be 10 wide, and we should say, maybe let's make that 30 wide instead. And we can hit enter. Now it's 30 wide. We can finish our sketch by pressing this Finish Sketch button. And then if we go forward in our timeline, we see, hey, our extruded part has actually changed. So you notice we did not have to do the extrude step a second time because the extrude was already done. Instead, what we had to do is we just went back in time, we changed this first sketch, and now when the extrude happens, it happens on that new, longer rectangular sketch. So this history timeline is something we might see a couple times as we are working on things. Very, very useful. It is, I should note, possible to work in Fusion without this timeline. You can, I think, go up here on your main project and right-click, and then there's something at the very bottom that says do not capture design history. Unless you have a really good reason to not capture design history, I would recommend keeping it turned on. It's very, very useful to have, and it's kind of a pain to not have. But say if you import a model from some other CAD software, by default, this will probably be off. So if you do turn it off, which I'll do real quick, so it says it gets removed and further things won't be captured, so it gives you a warning. So you usually should not do this, but if you do end up with a model that does not have design history, so say if you just imported this from somewhere, you can also right-click on this and turn it back on. Now the last option turns into capture design history, and you can click on that and then you get the history back. But now you see it's just this big base feature here. We no longer have our sketch. It's like gone, it's vanished. The extrude feature is vanished. We can't go back in time and edit that. It's just this one block feature. So that is why you might want to always keep it on and avoid turning it off, because once you turn it off, that information is gone forever, kind of thing. But that's something we'll see more of as we go. Cool. Okay, so we've seen how to form rectangles and extrude them. We're making some cracking progress here. Let's take a look at some of the other tools. So I'll just get rid of that. We'll make another sketch. So remember, to make a sketch, there's a couple of different ways we can do it. We can either do new, create a sketch, or we can turn on the origin and do a right click. I'll just click new sketch. We pick a plane to put it on. We'll put it on this ground plane again. So we'll put it there. Then we can take a look at some of our other sketching options. So if we look down here, we see a whole bunch of them. So there are rectangle options. There's circles, which one of them is under a C. So if you press the C shortcut, you get a center circle, and you just place where the center is, and you drag it out to whatever you want the diameter to be. So 100 millimeter diameter circle, looks like that. You can create that one there. Another useful shape might be the arcs. So the arcs here, there's a couple different types of them. If we press the S key, remember that brings up our toolbox, and we type arc. We'll start with a 3-point arc. So this one, I believe you give both end points. So there's one end of the arc, there's another, and then you can kind of drag out the arc this way. And that can be whatever size you want it to be. You notice that that's blue, which means that's unconstrained, so you can actually move this around and change the size because we haven't specified the size. To specify the size of something that doesn't have a constraint by default, you can use either this tool up here, which is sketch dimension, so you can click on that, or press the D key on your keyboard, and that brings up this dimensioning tool. Then here you can see it lets me set the radius of this arc, so the radius will be 30, say. You notice now it's still not fully constrained because it's blue, and that's because these endpoints can actually be grabbed and pulled, so the arc is of a different size that way. To sort that out, you can do some other constraints. So say if we wanted to stick this to this circle here, and it's also, I should note, not actually connected to anything on the ground either, so the whole thing can move. But to start constraining it, first thing we can do is look at the horizontal and vertical constraint, which is this one here. Unfortunately, or tragically, most of these constraints don't actually have keyboard shortcuts associated with them, but luckily, of course, they're in our sketch toolbox. So if we type horizontal, or just start typing it, and then we can hit enter, we have our horizontal and vertical constraint. What this does is make sure that either 2 points or 2 lines are either entirely horizontal or entirely vertical. So if we wanted to put this point and this point on the same horizontal line, after we select this tool, we just select this point here, or it was already selected because it was blue, and we select this point over here. And now you can see that it's moved up here, and those are now on the same horizontal plane. So now when we drag this around, we can still slide it forwards and backwards, but we can't slide it up and down anymore. You can see I'm moving my mouse up, moving my mouse down, and it stays on that line because it's constrained to be horizontal with that middle point. If we want to further lock it in this dimension, say, we can pop back up our dimension tool with D. So we press D, which is the same as pressing this button up here. We can press our 2 points if we want to find the distance between. There we are, and we can say, I want those to be 65 millimeters apart, and then hit enter, and then we're there. Now, slightly, trickily, or annoyingly, or subtly, this has turned the line black, which would make you think, yes, this is a fully constrained arc, which it is, somewhat, but you have to notice that there are still these points on the end, and these are unconstrained. So even though the arc itself can't change in size, so if I grab the arc and pull on it, I can't do anything to it. I can't move the center point anymore because it's all locked in. These end points are still flexible, which is a good thing to look out for because it turns black, but it's not actually properly fully constrained until these points at the end are gone. So to do that, say maybe we want to make a really ugly lopsided 2-segment snowman, and put that point like on that line kind of thing. What we can do for that is use the coincident constraint. So that means that some point is on top of a line, or that 2 points are on top of each other, or something similar to that. So we can do coincident, and click on that one. It's actually already selected because it's blue. Then we just click on the thing that we want it to be touching, which will do the circumference of this circle. So we'll click on that, and you can see, zoop, it's gone, it's connected it to that, and importantly, that free circular point here has disappeared because it is no longer unconstrained. So if we take our thing and we try and drag it around, we can't move that anywhere. We can move our mouse as far as we'd like. That arc is not budging. Finally, we'll do the exact same thing here. So we'll pop back up our coincident constraint again. There, and then click on this line. And finally, we have a pretty fully looking, or put together thing here. One final thing we could do, if we felt like it, you can trim sketches. That's what this modify thingy here is. So you can either trim with these scissors, or you can press the T key to get you in trim mode. This lets you delete certain segments. So say we didn't want this segment separating these 2 parts, we just want it to be one shape, we could get rid of that one there. And now you see it's one fully constrained snowman-esque shape. Then from here, we can press escape to get out of the trim mode, and then press Q to get into the push-pull mode. That automatically puts us in the side. We have press pull, select this face here, and then we can pull it up or down, or give it some size. And now we can have our snowman in 3 dimensions there. Take a look at him. He's beautiful-ish, kinda. So sort of snowman-esque design. I think in our second session, or maybe at the end of this one, we'll take a look at a slightly more advanced tool that will let you say, we'll take a look at it now. Why not? So if I go back here to my sketch, we can be done with our sketch. We can finish it off. You see it's still being showed by default because we haven't extruded it or turned it into anything 3-dimensional yet. There's also a tool called Revolve. So what Revolve does, it shows it a little bit here. There's that blue selection that you can see in that example picture. So that is your 2-dimensional sketch. And what Revolve does is take a 2-dimensional sketch and rotate it around some axis. So that if we took our snowman thing here and rotated it around an axis right through the middle of it, we could get it to form like an actual round snowman. So we'll try that. We'll click on, well, the profile was already selected, you see. So now the next thing we need to select is the axis to rotate it around. Our origin has very helpfully appeared. So we can select this red line here, which is part of our origin. That's the x-axis, and that's going currently right through the middle of our snowman. If we click on that, and then 360 degrees is fine, I think. Try moving the profile. Am I being silly? I might be being silly about how it's actually rotating things. So maybe I need to pick a different axis here. So if I unselect that one, and we select a different one instead, say the green axis, which is hiding way back here. Is that one better? Okay, so maybe it doesn't quite like it when it's in the middle there, so I'll have to take a look at how we can revolve that a bit better. But we'll jump to that probably in our second session, or maybe at the end of this one again. I guess it doesn't want to rotate around its center axis, so maybe it needs to be an axis outside of the actual thing. But that's alright. There are other ways to form that shape. Cool. I think the next thing we can probably do, there are certainly plenty more tools, but I think most of them will come across kind of organically as we're doing things. I think we'll probably start on that first little exercise thingy in a second. Before I do, I'll ask how people are doing and if there are any questions. So if there are any questions, feel free to type them. Otherwise, I'll ask, how are people following along and feeling about constraints? Cool. Any questions that people have so far about either what we've done or why would we do what we've done? I can see Philip is typing, so I'll let him type out his question. How do you create one blob out of the two blobs again? Good question. All right, so we can go back to our sketch real quick. I wonder if it'll let me undo straight through that. Yes, it will. Right. So here are our two blobs. The way to get rid of this middle segment is to take this trim tool, which you can grab with by clicking these little scissors, highlighting this. It shows a red segment for that bit in the middle. Then you click on it, and it'll go get trimmed away. The alternative is to press the T key on the keyboard. T key brings up the exact same trim tool you can see, and you just give it a nice little snip. Awesome, cool. And then Maria, you were typing there for a second. Did you have a similar question, or was it related to that one? Have I answered it? Okay, no worries. If you do want to ask a question again at some point, or if it was, another one, feel free. Cool. Alright, with that in mind, we might then look at forming this first shape we have. So I'll press just Control-N, brings you a new document, so you see it creates a new one up here. And you have like tabs, like you would in a web browser, that you can switch between them. I'll just toss away our snowman. Sorry, snowman, but I don't care about you. Goodbye. Ha ha ha. Alright, and we're back to an empty document. Excellent. So, from here, I think what we're going to try and do... again, not Linux. Oh, so much more difficult in Windows. That's the one. We're going to try and make this part here. So, these are a set of exercises. I actually have no idea where these originally come from. These might come from some mechanical engineering module. I think I got these from an engineering student who got them from GraphCAD, who got them from, I assume, from the photocopy nature of them. Some sort of university module. But regardless, it gives us some dimensions. Most of the time, these are everything that we'll need to make the shape. There's a couple of these examples that seem to be missing a dimension here or there. And then a way we can check that is this answer sheet, and both of these, by the way, I'll make available on the Bootcamp website once we're done with this session, so you can give them a go on your own after the session if you'd like. They have answers here, so these answers either come in the version or in the form of an actual 3D model that you can take a look at and play around with. if it loads, it takes a second. So you can actually look at the model and you can do like measurements and stuff with it, and that's all online. Or it also gives you a kind of way to check if you've done it correctly without needing to do that even, and that's by figuring out the weight of your part if it's made out of this material. So I'll show you how to set the material of your different parts, and then obviously the weight is related to this material and to the volume of your part, and the volume of your part is directly related to its shape. So if you have the correct shape, you'll have the exact same volume as they do, so you'll get this same weight. If you've done something wrong, that number will be different, then you can take a closer look kind of thing. We'll see that in a minute. First though, let's try and create that. Can we fit these both on the same screen? Time to get brave. Alright, I think that if we... Whoa, hello Fusion, you do not want to be resized, do you? In fact, you will not be resized. Alright, fair enough. Boop, boop. You can see my computer's a bit squirrely about the multiple monitors as well. Okay, and I'll zoom out a touch there, and slide over. Is this acceptable to look at? Can people see this part at an alright zoom level, and also still see Fusion decently? Is that all good? Alright, sounds good. Alright, well then, let's get to making this shape. We'll start with the easy question. Alright, here's Fusion. I would like to start making something. What is the first thing I should do? Any ideas? And again, instructions don't need to be exact, just keywords work as well. I would agree with you, Philip. Yes, I think we should create a sketch. And there are, of course, several ways to do that. For now, we'll just press this Create Sketch button, because I think that's the fastest way to go about it from nothing. Then we pick a face to put it on. I'll put it again on the ground face, there. This is treating Z as if it's the upwards direction, but there are different conventions for that. Alright, so here we are. I would quite like to create a rectangle, because that's the base of this shape. And I'd like it to be centered around this origin. So, perfect shape for that would be center rectangle. I'll press my S key, and S pops up this shortcut searching menu, and I can type center. And you see there's a couple different types of center. That's actually probably not the most helpful, so maybe if I type rectangle, here are different rectangles, I can use my arrow keys, and then click on center rectangle. You can also see I've pinned it up here in my shortcuts, so I could just press S, oops, recs. I could also just press S and then press this. Those are just different ways to get to that. If you want to get to it the other way, you go here, create, rectangle, center rectangle. All of those are entirely equivalent options. So I'll go ahead and do this one. That's the fastest one for me. And we'll put our center right on the origin, which is this place here. You can see it kind of snaps to the origin. Once you get close to it, it draws a little blue box around it. So I'll put it there. Then we can drag out our rectangle. From our sketch, or our design blueprint here, you can see, I mean, somewhat annoyingly perhaps, they've decided to just replace this with a letter, which then you have to look here. So that's just 100 millimeters in that direction. And in this direction, you have 60 millimeters. So we can go here, grab our center rectangle, place it, and we want this dimension here to be 60, and then I press Tab, and then I can type in the other dimension, which is 100, and I can press Enter to finish the shape. And there we are. So this, you can tell, is fully constrained because it's black, and there are no open points on it. Now here I can just press Q, which is my press pull. I click on this face here, and I want that to be B, tall, which in this case is 40. So I'll type 40, and then Enter. Now it looks very two-dimensional still, but that's just because we're trapped in this upwards view. If we just take a look around at the side, we can see this is in fact three-dimensional and is exactly what we're looking for. Cool. So say we're looking at it in this way. That's the same way, kind of ish perspective that we're going for. We can click on this corner here. Maybe that's the perspective that we're looking at it from. So far, so good. We have a lot still to add, but we can get to that. So Let's see, there's actually a couple of different ways we could do this. So we'll make this part in a couple of different ways so I can show off a bunch of different tools. First one I'll do, now, once you have a three-dimensional object, you'll notice when I'm floating over these faces, they get highlighted, right? So we could still, of course, do create sketch and then click on a face, and then we can write a sketch on this three-dimensional face. However, there's a nicer way to do that sometimes. You can also just right-click on a face and then create a sketch right here. So that's probably, I think, what's the easiest. You also have a repeat option, which repeats whatever you did last. So if you last created a sketch, then you can just repeat it there. But I'll just create a sketch on this thing. And then what I will do is make a big divot here that will correspond to this sunken down region. And this actually, the first way I'm doing this is kind of by bad luck on my part, not the best way to solve this problem. So I'll show you a better one in a minute. But here we can still solve it because we know how thick that, well actually, yeah, this will do. First thing we'll do is we'll create a rectangle here from the bottom. We'll make it just some arbitrary size. You can tell that's blue, it's unconstrained, so that means it can change size. So that's actually fine. We know that this wall up here on the left should be 20 millimeters, so it should be 20 millimeters between these two lines. So we can press our D tool to get our distance back. Actually press escape, unselect that. Press our D tool, click on this line, click on that line, go down, and we can say 20 millimeters, please. Lock that one in. Now that one's black, you see, so we can still slide this up and down, but this cannot be slid left and right anymore. We do the same thing with this line, except this one, well, actually also 20. So we'll press D, click, and click. There, 20. So there we are. There's our general wall shape. So now from here, we can press our Q, our press and pull. We'll select this face. We want to shrink that down so that it's 10 millimeters away from the bottom face. So you could do this by doing a bit of simple maths in your head. So we know it's 40 tall in general, and we want 10 left at the bottom. So we could do -30. That pushes it in -30. I think, I'm actually not entirely certain if we can do it this way, but I'll give it a go. If I try to object, yeah. So you can switch up here. You have some options. So by default, you have distance. And that tells you what distance you would like to extrude. You can also say to object, and then you can select something in 3D space. So I'll go down and select the bottom. If I select the bottom, you can see it goes all the way through and cuts out that bottom piece. It'll go all the way to that bottom face. And then from here, I can also set an offset. And I could say, well, okay, go all the way to the bottom face, but offset that by 10 millimeters. Or maybe in this case, it'll be -10. So that'll leave our gap of 10 at the bottom. Those are different ways to do it. We'll see an even different way to do it in a minute. I'll do this one for now. Why not? Okay. Now the advantage of using that to object as opposed to just giving it a distance, and I can show you what this difference is. So if we go here, this is our shape we have now. That is 10 millimeters tall. We can actually measure that. There's an inspect tool here, so you can click on that, and then you can click on like a line segment, for example, and it tells you that's 10 long, so it's 10 here high. You can also get to that with the I on your keyboard. That'll bring you to this same inspect menu, so you can press I and then click on things. If I would go back in time to this first extrude, and I make it bigger, say, so I'll make this 60, so now it's taller. This stays 10 down here at the bottom because we told that cut inwards to go all the way down minus this little gap of 10 that it leaves behind. If we were to do that differently, so say we'll go back here, back to before we've cut it, press our Q, click on that, and then we just take it down, say 30. Now it's constrained to always be down 30, but that might not always mean leaving 10 at the end. So here, because we've done the maths, it leaves 10 at the end, exactly what we want. If we were to go back in time and change how tall this thing is, so say make it 60 again, now you see it's a totally different shape. And this size here has gone all the way up to 30 because we're just subtracting 30, not actually going to an offset of 10. So that shows there are different ways to do it, different design practices. In the end, of course, your result will look the same either way, but it's generally better practice to do the to object because then it makes it easier to go back in time later. But it's all a preference thing. I will undo a couple of times. Then we'll go ahead and do a push-pull here, and I'll do the two objects. You can see that again. So here you're in distance mode by default, but you can go to extent under the extrude bit, and then from here you can go to object. I want to go all the way to the bottom, and then the offset, okay, all the way to the bottom, minus 10. Or not 100, minus 10. There we are. And then we can go ahead and hit enter. Excellent. Alright, so we're here. If we click on that, it's probably a pretty similar looking view. Now, for anyone feeling keen, what is our next step, do you think? There are a couple of different ways we could go about making these last two cutouts here. What do people think? What should I do? Where should I do it? Any ideas to make this shape? Yes. How do we change the direction of the dimension? How do you mean, Maria? Do you mean... yeah.
Like when I wanted to put the dimension as 20 centimeters horizontally, the command was vertically.
Ah, yeah, so you mean presumably back here in the sketch bit, right?
Yeah.
Yeah, so when you click on a line, it will by default just assume that you're trying to give the size of the line. So if you're right, and if you do D and you click on that line, you'll see this, which I assume is what you see. If you just click on a second line, it will switch automatically for you, and I'll give you the distance between. So I clicked on that second line there.
Okay, thanks.
No worries, happy to help. Cool, yes, that's a very, very good question. That's something that you'll probably run into decently often. Yeah, sometimes it'll try and assume for you and be smart, and sometimes it assumes wrong. If it assumes wrong, you just need to give it a bit more information. Cool. Any ideas on what we should do at this point to make these cutouts? And remember, we can create sketches on faces if we want. So I don't know which faces we should do that on. Any ideas? There are several correct answers here. Any ideas? The crowd goes wild. Okay. So what we can do from here is the same thing that we did when we made this cut. Yeah, so top face. Yeah, so we'll do that one. Yeah, it's actually probably a better one because we can do it all in... I'm not sure if it's better, it's equivalent. So if we roll over this top face here, we can right-click on it and go to our Create Sketch. If you don't like the right-clicking thing, I think the right-click is nice and fast because you can, just right-click and then go Create Sketch. If you don't want to do that, you can also do Create Sketch up here and then select this top face. Both of those are equivalent. I'll move here. Now we're looking at it from the top. So we can think about these two cutouts that we need to make here. This first cutout that we've got, we know is going to be 30 wide and then 10 deep. And it goes across this whole thing. So we can grab our rectangle tool by pressing the R key. Then we can go ahead and say, click on this bottom corner, and then go up here, click there. And actually, that'll already be kind of the size that we're looking for. So it'll be unconstrained if I don't put that in. You can see, of course, that since the blue line, that can be any size. We, however, want it to be a particular size. We want it to be 30 millimeters from this edge. So in addition, when I was showing off how you can constrain the distances, you can also, when you have a rectangle like this, you have several options. So I could do what I showed Maria and did earlier, which is click on this line first, then click on this line over here, then you get the distance between the two. Alternatively, you can just click on, I need to unselect those with escape. I can just click on the dimension thing, and then click on one of these lines, which is just the side line, and then I know, aha, this one also has to be just 30 long. And then you can see it's fully constrained, it's all black, nothing to wiggle here. Then we'll do the same over here. This one's a 20 by 20 cutout, so I'll press R for my rectangle key, drag that up here, and then I'll press my D key to get a constraint of the distance. Press this line, and that's already 20, that's fine by me. Hit enter, now it's fully locked down. I didn't need to do that. Yeah, wonderful. So that's all constrained. From here, we can do our push-pull, or press-pull, so I'll press Q To get to that immediately, so that's our press pull. Then I can click on this top face here. How far down does that one go? Well, our sketch says that one goes down 10. This time we can use the distance, because that's what and it's best to use the distance, because that's what our sketch gives us. It says go down 10. Then we can also do the same thing over here. So you'll notice, actually, our sketch has disappeared. That's because we've used it once, and Fusion is like, well, clearly you're done with that, which is a bad assumption on its part, but it's usually correct, I guess. But it's not super clever about it. So to get that back, what you can do is go into Sketches, so this folder here in your little project tree, click to unfold it. Well, if you were doing this well, you would name these sketches. So you can click on them twice, kind of slowly, to get to the point where you can rename them. So this could be like the base sketch or whatever. But it's also ordered. So the last sketch we made, we know is the one that we're interested in. So we click on sketch 3, make it visible again. Then we can see our shapes again. From here, we can do our press pull with Q. Grab this one, go -20, type enter, and Fusion will think for a second, and there we are. We can re-hide those sketches, and our shape is all done. So, what if we want to check our answer in this particular case? Well, we can set the physical material of this object. So we can do that. There are, of course, as always, several ways to do it. You can go up into Modify, maybe? Yeah, Modify, and then down to Physical Material. Or the much faster way, I think, press S, start typing physical, and then there you are, physical material, enter. Then you have a bunch of things that this can be made out of. You can make it out of ceramic, or, so we could have a porcelain part or something ridiculous like that. For this particular set of exercises, they're using aluminum 6061. So we'll go down to metal, because aluminum is a metal, or aluminium. Oh, sorry. Oh, that's the yucky American in me. Aluminium. We'll go down to select aluminium, and you can see there's a bunch of different options. And somewhere on that list we'll have, and it's obviously sorted by name and then number, we'll have 6061. And you just click on it and you drag it on top of the shape that you want to apply it to, and then let go of your mouse button. And then you see the color changes slightly, and it's been turned into an aluminium shape. Now what we can do to get some information about this is we can right click on it. I think if we do properties from here, yes, that's just the properties of the face. It tells us that it's made out of aluminium. But what we can do to get the whole body is we go under bodies, and then right click on the body itself, and then from there we go to properties. And this tells us the area, the density, and the mass, and the volume, the material, which is aluminium 6061, what the appearance looks like, center of mass, other information like that. We're interested in the mass, which says here that it's sorry, probably a bit small to see, but it says here that it's 351 grams, which is in fact what we have over here. 351 grams is the expected result for this shape and this material. So that's our way of knowing, okay, sounds like more likely than not we've done this model correctly. So that's our little answer checking. Additionally, it's a separate section of Fusion, and it's not quite as unrestricted as the design one. So the design one, you have most all the features in here. Some of these other ones, though, require cloud stuff, which is really annoying and terrible. I mean, okay, right. That's a lot of Brooks's opinion. It's fine, and lots of people use it that way, but it sometimes requires that you have to pay for cloud credits, and you send off your work to not be done on your computer, but to be done in the cloud, so on somebody else's server. There are still some things you can do locally, though. So if you go over to render, you can see this here, and you can do in-canvas render. And you can take a nice, pretty look at your aluminium, and you see it generates a much more photorealistic version. It takes some time to get there. This is doing it on my computer. Then you can export this image or something. So this is how you can create really nice pictures of your designs to share with others. And they're much more realistic looking than just the ones in design. But this workbench we won't jump much into, because realistically it's just for making things look pretty, isn't actually functionally something that you'll need very often. So we'll just jump back to design, which is where we are here. Alright, excellent. That is our first part, so I will go ahead and ask, are there any questions about anything we did in that process? For the people who are trying to follow along, have you gotten to this exact same shape? If so, have you gotten the same mass of 351? So I'll ask how people are feeling about this. First shape. And that is an excellent question, Maria. And it's very good that I looked that up exactly 5 minutes before this section. So the difference is really quite subtle, and you'll only see it in a couple of places. But for the most part, well, okay. Press pull is a bit more diverse. When you go to a press pull and you click on something, you see, well, okay, in this case it's actually on the offset face. If we go to our sketch, we'll create a new sketch actually. So new document real quick. I'll create a new sketch on the ground. We'll make it out of 2 circles. So press C once, draw a circle, and then draw another circle. Note that you don't have to actually have things constrained, so they don't have to be black to use them. They should be if you're designing anything really important. So definitely try and aim for that, but they don't have to be. So I'll press Q. I'll click here so it's currently the press pull, but if I click on this, you see it changes into the extrude tool. So for things like this, it's exactly the same. They're identical. So it's just like doing an extrude there. A superpower, however, that press pull has is it can also work as something for offsetting faces. So if I press Q again, we have press pull, select this inner face, now it's turned into offset face, and you can see this is something that extrude can't do. I can move after the fact, after the shape, this thing here, I can make it bigger or smaller, the inner face. I can do the same thing on the outside if I wanted to do so. So that is a different operation. And there's one more different thing that it can do, I forget. You can definitely check the documentation for it. For our purposes, it's the same as extrude for the most part, but it is a bit more flexible and it's smart about what you click on. Yeah. But yeah, for our purposes, you are correct. It's basically just extrude. Extrude is there. You can get to that with the E shortcut. That does kind of what you would expect it to do, which is just our same as a press pull there. But you can see if I select the E tool, I cannot select this interface. It has to be a flat one. So that's how those tools are kind of different. Very, very good question. Are there any other questions? Seems like people are feeling all right about the first shape, which is good from the poll. Awesome. Okay, let's see if any other questions come in. If not, we'll look at this next shape. Cool. All right, this next one. How to undo a fillet. Hey, good question. So we haven't quite gotten to fillets yet, but if you press F, or if you click this up here, so I'll press F. Oops, I'm not selected on Fusion. If I press F, then you can go here and apply a fillet, which is like a curve on a surface like that. It's really nice for some parts. Makes them look pretty. You can select several lines to do it on. Make something nice like that. The way to undo it, general undo is, so I'll apply that. General undo is just Control Z in Fusion. However, if that's not working for you, or if that doesn't do quite what you want it to do, you can look down in your timeline here, and a fillet is its own timeline item. You can either move your timeline cursor, which is this thing here, back behind the fillet, so it goes back before time, so the fillet never happened, or if it's got other things in it, so you can actually reorder items. So if we put that there before that extrude, so you see now, if we go back in time to before the fillet, we also lose this feature here. If that's the case, then you can just click on that individual feature and then press your delete key on your keyboard, get rid of it, now it's gone. Does that answer your question there? Awesome, cool. Neat. Anything more? I think this next shape is pretty similar to the first one in terms of like no new tools, so I think I'll try and ask for more suggestions this time around. Awesome. All right. If there are no further questions, and if there are further questions, feel free to ask them. But otherwise, this is the next shape we're going to try and make. Here are all of our dimensions that we're going to work with. These little holes, so like look, there's a hole, it's kind of been pushed in. We're assuming for all of these parts that all these holes go all the way through the entirety of the object, so that they go all the way out the other side. If that's the case, how should we start this design? There's always a bunch of different ways to start it. We can start with a sketch on any face we'd like. So what do people think? I'll go ahead and create a sketch, because I'll give you a spoiler, that's probably the best place to start for most things. Which side of this object do we want to sketch first? Up to all of you. Which axis should we go on? Bottom one, this one here, that one there. So I guess, I don't know, that's the XZ, that's the YZ plane. Any place that seems natural to start for everyone? And remember, there's probably not a wrong answer here. It's just different correct ones. Any opinions? What on the x this time? By x, do you mean this one here, the xz plane? I'll assume. Sure thing. Cool. Right on. Let's draw it there. Alright, so now we're looking at it from the side. At least in my head, we're looking at this face here. So there's a number of different ways to design that. What should we design here? Oh, I forgot to show you one of the most basic tools. If you either go here and click that, or if you press the L key, you get a line. And you can draw line segments, and those like connect together and things. So we could do something like that or whatever. So that's one option we have. We'd also do like a rectangle or something. Anyone have any particular ways you'd like to start? Line segments, rectangles? Anything they're feeling? This is always much easier when we're in like the same room and people can shout at me. Cool. Alright, I might make an executive decision then. Alright, I think for my executive decision, I will do this one with line segments. We can see how that one looks. I'll say arbitrarily that this red line here will be the base of the part. And I'll just sketch the general shape. And even here, there's a bunch of different ways that you can sketch this shape. I'll go ahead and press my L key. I'll go here, I'll go back a bit, and I'll click there, I'll go up, and I'll go over and up again. And then we'll go over a little bit, I'll go down, over, and down again, and collect there. And you can see when we close the shape, it turns all solid blue. Now, if you noticed, when I was going around there, that was incredibly imprecise. But that's entirely fine, because the whole point of adding constraints after the fact is that we start with something that's just a really vague sketch, and we narrow it down to be something concrete that cannot possibly be anything different. So, to do that, first we'll add this A dimension, which is all the way across the bottom. So this part, all the way across, is 110 millimeters. So I'll press my D for a distance constraint. That highlights that sketch dimension. I'll click distance from that line to this line here. Hey, I was actually concerningly close. 110 there, so that shortens it up a little bit. I can... does it matter if this is centered? It would be much easier to center if we started with like a centered rectangle, which I did not do. We've done it in a bit of a strange way. But that's alright, we can center it kind of after the fact by saying that from this origin point to this edge here, that's going to be half of this distance, so it's just going to be 55. So there we are, now we have that center axis there, centered on the origin. The height of this segment, you can see is 40, so there's a gap of 40 between up there and down here. So I'll click on that segment, that one is, well, already 40. Concerningly accurate. The total height of this shape, so from all the way to the top, all the way to the bottom, that is B, which is 60. That's, again, ridiculously already correct. Then across the top here, we can actually do this several ways. So we could either think that it's just this front face, or we could include this back face. I'll think just this front one. And we don't have a dimension for that easily available. So actually I'm going to do this whole face here. So I'll go 80 up here. That's going to change the shape quite significantly. That's also including this back part. The height of this is 30, so I'll go ahead and click here. Already 30, how convenient. Which means the height of this, well, that's already fixed actually. Coolsy. So something here is unconstrained. Yeah, that's going to be like the width of this, for example. So that there is going to be 20. We know that from this constraint there, so that's 20 long. Let's see, how far is that inset? We already have that specified, so let's see, what is wiggly here? Aha! The whole position of the thing. Would you look at that? Right, so it's wobbly because I just said that that point there needs to be that distance away from the center point there. There's a better way to do that. Several ways to fix that. I'll currently just use the coincident one. So that means put this point on this line. So put the center point onto the bottom line. There. Finally, we can see the whole thing is turned black, which means it's fully constrained, and we can extrude it. So, I will go ahead and do so. So I'll press Q for our push pull. I'll click on this, and how wide do we want it to be? We'll make it C wide, so that's 50. So I'll just do 50, and enter. And there you are, we pushed it over 50. So now we have this shape. Not quite perfect, but it's certainly in the right direction. First thing I might do is take a look at this cutout down here. So that's on this face, on this side, so I can right-click on that. Go ahead to Create Sketch. Now we're on this face. I'll create a rectangle, so I'll click R to get my rectangle tool, drag up a rectangle, add some dimensions with D, so dimension for the top is 15 wide, that's 15 wide. Dimensions for this bit it's 10 tall, just like that. Now you notice this is unconstrained because it can slide forwards and backwards throughout this whole segment here, so we want to put it in the middle. There are a couple ways to do that. What they've told us here is that it's just 15 of space on either side, so we'll follow their instructions and do what they want us to do, which is nice and natural, so we'll click on that, and then on this edge there. Oh, whoops, that was the wrong edge. So, escape a couple times to unselect all that. Click there, and make that 15. You'll note we don't need to repeat the second one because we've already given the width of this, so it's all turned black, fully constrained, no open points. So it's all fixed there. Cool. Actually, this whole thing seems a bit thicker than it should be, doesn't it? Have I been silly? Yeah, okay. So I've misread this design here. The design, I originally thought said that this middle section was 15 wide. That's not the case. That 15 is referring to this gap over here. This 15 is referring to this gap over here. It doesn't actually give us the size of the cutout. So I need to delete this constraint, so I can select it, press the delete key. Now you can see it's variable again. I can press my constraint, or the D for distance constraint. Click on that edge, and this edge, that should be 15 apart. So that actually makes the middle thing 20 wide. So there you are. Now it looks a bit better. That's right there in the middle. Then we can do what we're used to. Press Q for our press pull. Press that. Now here is an excellent use case of the extent to object. We want this cut to go all the way through. So we can click to object, then we can go in our 3D space, spin around, click all the way out to that face. Then you can see, shoop, cuts all the way through the middle. We don't even have to know how far that is. Then we can do OK, and it's done. So there we are. It's coming together gradually. There it is from the perspective. We need to make 2 more cutouts probably. So next one we'll make maybe is this one here. So I'll go ahead on this face, right click, create sketch. We'll do rectangle with the R button, build a rectangle that looks like that. You can see I already clicked, so it's stuck to that corner, which is good, that's what we want. We want this distance here to be 25. So I can click the D for distance constraint, click on this edge, click on that edge. I would like that to be 25 away. Now it's fully constrained, it's all black. Q for press pull, click on it. We want this to go in 30, so I'll type minus 30, enter, and it goes back in 30. Repeat the same process on the top. So on the top, we're going to do right click and create sketch. We're going to click R, create a rectangle, just like that. Then we can go ahead with our dimensioning tool and say from there to there, it's supposed to be 10 millimeters, and it's supposed to be the same distance on the other side. So there we are, 10 millimeters. That's what our design has told us. How far in does that go? Well, here is one of those cases where this design is ambiguous, which is very annoying, but I assumed, and I think it's the correct assumption if I recall correctly, that this is also inset by 20, just like this is. So it's the same amount of being pushed in as that is. So in that case, we can say this size here is 20, or I can show you a cool feature. If you would like to include some line from this three-dimensional object into your sketch, you can project it. So if I press well, first I'll show you where it is graphically, which I will have to look for. If you go into Create, Project and Include, and then Project is way down there. It has a shortcut, P. I would definitely use that whenever you can. So if you click the P button, you get to this Project menu. Now you select, it just says Geometry, so that can be anything in this three-dimensional setup. I'll take this line down here. So that line I'll click on, and now you can see, up in our sketch, it's been projected in as this purple line. So I'll click OK or Enter. Both of those will finish. I'll get back to my top view for my sketch. So if we want that to be in the same distance, then all we need to do is give a constraint. So we could do a coincident constraint and say, hey, put this point on this line, and that fixes it. That's all black, all constrained. An alternative approach would be to look at a new constraint that we haven't seen before, which is collinear. So this means that they share a same or a common line. So if you want like two lines to line up end to end with each other, you can select that line, and that'll bring them together. That's just another way to go about it. Excellent. And of course, if you didn't want to do any of that faffing about with projection, you could definitely 100% just do the calculation in your head, or just look at this and say, hey, that's 20, press D, and assign this to 20. All of those are entirely equivalent options, with some slightly different, side effects down the line. I'll do the coincident one. That's nice and short. There we go. Stick it that way. All black. All we need to do. Q for press pull. Click on that. Let's do extent to object. Look at the bottom. Go all the way through. Whoops. Hello. There we are. Clicked on the object, and we go all the way through. Okay. There's our cutout. So, I believe, I might be being silly and forgetting something, I'm sure I am, but I think that is our complete object there. Well, we can double check. Press S to bring up our little menu, and get physical material. Assign the aluminium 6061, which is there. Click, and drag it over, close that. Go to the bodies, get the property of the body, and we can see it is 519.75 grams. And over here we see 519.75 grams. So we know that that has the same volume, which means probably the correct shape. Does anyone have questions about that? I'll create a poll to see how people are feeling. In the meantime, please type questions about anything about that shape. Anywhere you got lost, if you were trying to follow along, I can help unlose you, hopefully. So, cool. And that one's a pretty similar one to the first one. So we saw a couple of new tools there. Why do you do the same? Repeat the coincident part, please. Yes. So I assume you mean when we were up in this sketch here, where I stuck this line to that projected line. Have you gotten to the point where you've projected this line from down here? So you have the purple line in your sketch. Maybe that's the case. Can I select that? Oh, interesting. Oh, there's like 3 different things there. Oh, or is that what this is? Okay. Yeah, so I can repeat the coincident part. I'll see if I can undo just past that. So, there we are. So, for this part, the coincident constraint is this one up here. Also, I've been grabbing my constraints from up there because they're just visible. You can also do the S, though, like I said before, and do coincident. And if I had the coincident thing, you just pick a point somewhere. So I'll pick either this corner or this corner. And then I can click on a line where I would like it to go. I'd like it to go to this purple line. So if I click on that, it goes ahead and extends it for me and locks it in. Does that answer your question? Or was your question about some other coincident point? Awesome, cool. Happy to help. Neat. Finish sketch. And, whoops, I undid my press pull. And extend to object. Click bottom, and done. Alright. Awesome. Any other questions? Or shall we move on to the next one? Cool. Alright. If you do have questions, definitely feel free to type them on in as we go along, and I'll try and keep an eye on them. I don't think I've missed any of them yet, which is good. I think we'll jump probably past this part, because that one is good practice. This one, I'm not going to lie, I can't read lots of those numbers, so I didn't do it, but also, conveniently, neither did the people who made this answer sheet. So we'll jump then to this one here, which is our first medium complexity part, and is a bit more advanced than the things we've seen before. Wow, that was not what I intended to do there. I'll zoom out a little bit farther. Take a look at this. Right. This part, looking a bit crazy, right? I think, yeah, we got half an hour left, so I'll go through this one. I'll go through it decently slowly. There's going to be lots of new things around the way. And feel free to interrupt at any point wherever you have questions, and I will keep an eye on the chats. So, Control N to start a new document. I'll close and get rid of my last one. Destroy it. And we'll start on this. So looking at this part, it's a bunch of different ways to start it. Knowing where to start things is more intuition than like a right and wrong answer. I'll probably start with on the ground this circle bit. I'll build that on the ground and I'll just build it upwards. I think that'll be fine. So for me, I'll click Create Sketch, click on the ground plane, and then I'll click C to draw a circle. I'll click on this center point and I'll drag it out. Now, you might be wondering, how do we know how big this circle is? Well, I can first type the answer, which is 76, and hit enter. And the reason I know that is because you have this little symbol here. So this symbol that looks like a circle with a line dashed through it, that gives you the diameter of a certain value. So you can see here, there's a diameter of 76, which actually Fusion uses the same diameter symbol. And it's pointing to this outside ring there, so we know that's how big this ring is. So that is that. Now, if we want to say, which bit do we want to do next? We can do a middle circle. So it's a bit sneaky looking at this thing, but we know that there's a hole that goes through the middle of this part here. That hole starts here, and the diameter of that hole is given here with 20. At 20. The diameter of 20 millimeters. So you can see this arrow is kind of pointing into this inner circle diameter. So another thing we can do, click our circle tool again, draw a diameter circle of 20 millimeters. So that's the size of our hole through the middle. Now, I think what I'll do here is I'll call that as a simple first sketch, and I'll extrude this up a little bit. So I'll click Q, click there, type 10. This 10 has come from this measurement here, so we know that that's 10 millimeters thick. So there's our base bottom shape so far. Now, we're going to encounter something new. We want to place 6 holes evenly spaced around a circle in here. You can see from this design, it says there are 6 holes equally spaced is what the EQL-SP means. So equally spaced on a diameter of 58 millimeters. So what we can do there is click on this face. Ah, yes, we get to see a new thing. That's exciting. Create a sketch. We want to draw a circle again, and we know that that circle is going to be 58 millimeters across. But we don't actually want a circle here that we're like cutting out or extruding or anything. We just want to put other things on top of that circle. So if you want to create parts of a sketch that aren't actually part of the final design, but you can use as a reference, which is what we will be doing, then you can turn it into a construction line. So to do that, you can click on the line, and you can click this construction toggle here. And you see that's turned into a dashed line. So that means it's a construction line. So you can see now this is just one face. So we're not splitting this face in half anymore. When it wasn't a construction line here, you see there's separate face out there and the inside. Those are separate parts. But once it's construction, those are no longer different. You can also do that by selecting this and pressing the X key. Press the X key, and then you have your dotted line all the same. Excellent. So there's our template. We'd like to put some points on that. So something I can do, we'll design one of these holes. We know that these holes have a diameter of 8. That's what that means there. So a diameter of 8. I'll click my C again. We'll go up here. We'll draw a diameter of 8 circle. You can see that's blue, it's unconstrained, it's a big warning, big red flag, look at that thing, it's running around like it owns the place. So we want to constrain that to be in one place. We know that there's one directly in the middle, so what we can do is use a vertical constraint, horizontal or vertical. So we say vertically, I want that point to be on the same vertical as this origin. And you can see it locks it in there. From there, no longer blue, can't even shuffle around anymore. So it's right there in the middle. Now, we want to rotate it around this circle. So to rotate it around the circle, what we can do is use a totally new thing called a circular pattern. So you can get to that, of course, as always, in a number of ways, either under create, and down here is circular pattern, or what I'll be doing is just typing S, and then circ, and then you can see circular patterns down here. Go ahead and click on that, and you see it pops up a menu. First, it lets me select some objects. So the objects are the things that you actually want to put in the pattern. So I want these holes to be part of the pattern. And actually, there's a couple ways to do this. I'll show you both ways. So I want that to be the object that I'm rotating. This is my pattern. I selected that first. Then I can go and select a center point. Center point is going to be the center of this circle. Select that there. Then I can set the number of copies. There are 6 holes equally spaced. Type 6. Hit enter. Et voila. There you are. You've got a bunch of holes around. Now, there's a bunch of different ways that I could have done this in different orders. So at this point, I could do a press pull and grab all of these individually, and then push those all back into the bottom to cut them out. But that might not be the most convenient way. So another way that you could do an equivalent thing. So I'll cancel and I'll undo. Don't want to do too far, do I? So here we are, back before we've done things. So instead we could just take this singular sketch here, and with Q, take this circle and do a 2 object cut it out all the way to the bottom. Oops, there we are. And okay, so there we are, we have one cutout hole. Another thing that you can do is from this workspace here, you can also still do your circular pattern. So if we go back to the top, or actually even just a 3-dimensional view. If I search up my circular pattern and go here, I can now select a type of item. So I want to rotate a feature. So a feature is something on the timeline. So this hole was created by this extrude feature. So if I select feature, then I can select this feature here, which is this extrude. You can see it highlights it in blue in Fusion. Then I can take the axis. So this is a bit different from our sketch one, because now it's in a 3-dimensional thing. And I want to rotate around this blue center axis. And then I can say something like 6. And enter. And this time it actually rotates the full cutout, not just the circular sketch things. So that's another way to do the exact same thing. Lots and lots of options in Fusion. Awesome. So that's what we have there so far. This gross squiggly line here that's pointing to that, and then also to this, that means it wants a fillet there, so a rounded edge. We can apply that now, might as well, at least for this outside one. We can apply that by pressing the F key. That brings up our fillet, or of course you have this option up here, that's your fillet, a rounded corner. So I'll press the F key, I'll press this, and it tells us it is a radius of 2, so I'll go ahead and type in 2 for the radius, hit enter. There you are, nice rounded corner, all the way around the outside. Coolsies. Any questions about what we've done so far? We'll hopefully just be continuing on, there's plenty still left to design, but I don't want to wait too long to ask if people have questions. Or we can do a poll. Poll. Questions. What was the radius again? Yes, so the radius here is, do you mean what was it for, or what was the actual number? The actual number was 2. Yeah, so the radius of the fillet was 2, and that's given by this R2 value in this design right here. Yeah. Wonderful. Awesome. Okay. One person has selected either yes, they have a question, or I have fooled them because I've switched the poll back to being a negative question. Maria, did you have a question? I will take that as no. No worries. Sorry, just keeping you all on your toes, making sure you're awake, Alright, any other questions? Awesome. Cool, alright, we'll power onwards then. Next thing we need to do is this big column here. We're given the radius of the outside of this column is 36, so we need to make it a 36 around the outside, and we know that there's this hole here through the middle that's 20. We already have that designed in. So here I'll click on this face, right click on it. Oops, I wasn't clicked on Fusion. Right click on it, and then create a sketch. And from here, grab a circle, click on the center point, drag it out, make it 36, hit enter. There we are. Slap the extrude button, which is Q, or the push-pull. Select this donut shape here, and we want to pull that up a certain amount. There's different ways that we can calculate that distance. What it's given it to us, what it has given it to us as is this distance A, which is all the way from the bottom, all the way to the top. I'll show you something neat, why not? So first of all, we can set it to 70, which is the value of A. So that is a bit too long, because that's going to be including this bottom and top bits. But something we can see here is you can do maths in these little fields. So if I type 70 minus 12, which is going to be the width of this top segment, minus 10, which is the size of this bottom segment, that will give us the correct thing. It'll calculate it. It's 48. That's what it's calculated for us. So we don't actually even have to do that ourselves if we don't want to. And then go ahead and hit enter, and there you are. You have it going up the correct amount. From here, now we want to create this really weird face shape, and here's where we're going to see a bunch of wacky new stuff. So I want to create it up here, so I'll right click on this, I'll say create a sketch, and now things will get exciting. Yeah, it doesn't really matter which way I create it, so I'll create it this way. We're given a couple of little points. Reading these designs is honestly sometimes quite difficult. I'll admit the first time I made this part, it took me ages to figure out what they were telling me, and there are still parts of this that I think are disgustingly unclear. Like this radius of 26 is not actually, believe it or not, the radius of that outside circle, or sorry, the diameter of 26. But it's actually the diameter of this inside part, which of course they do a great job of labeling by putting the arrow in the wrong place. But that is not an issue. What we can do is take a look at these numbers here. So there's an R25, there is an R12, and what those means is that there's a radius from the center of this hole here out to this edge of the shape of 12. So it is 12 millimeters from there out to here, and it's an arc, so the radius is always 12 around here on the outside until you get to those straight segments. Similarly here, from the very, very center point out to this edge, it's a radius of 25. There's a bunch of different ways to do this. I've already done this in like 3 different ways when I've been doing this problem. One way that's pretty intuitive, make some circles. So we'll create a first circle here that is a diameter of 50, because it's a radius of 25. So if I create that, you can see there's my diameter of 50. Yep, that's right. Then we can do the same and create some other circles. And in fact, if you find this confusing to look at, which at this point, honestly, I find somewhat confusing, there's lots of circles there, you can hide the bodies just by turning off the visibility there. Now we get just our sketch. And of course, it's still there. We can just toggle its visibility on and off. So there's a circle. Why not? Stick with that. That seems cool enough. Yeah, that's fine. And then what we can do is add a couple of other points. So we know that from this center point out to the middle of that second hole, it is 38 millimeters. So we'll create a couple of holes out here. I should have given the sizes of those. That's fine. We can do that retroactively with D. Click on them. Diameter of these holes is 10, it looks like, for each. And that diameter is given here. It says 2 times 10 diameters all the way through. So that's there for one. There's the other one. Both the diameter of 10. Oh, actually, hey, we can do something cool here. I can show you a symmetry thing. So if you're doing something that's symmetrical, like we'll be doing here, real quickly we'll say that this is, how far away are you from the center? You are 38 away. So 38 away. And we'll give you a horizontal vertical constraint. so that you're no longer allowed to wiggle, so you're horizontally the same axis. Now you see they're both black. From here, if we want to repeat the same thing on the other side, we can use a symmetry constraint. So I would like things to be symmetrical about this middle axis. So I can click first on the... okay, so we actually don't want symmetry in this case. You have symmetry if you've already designed both of them, and you want them to be symmetrical already. If you want to mirror something, you can use the mirror tool. That exists either there, or, of course, in your S menu, where you can type mirror. So if you go ahead and do that, for a sketch mirror, you select your object first. So there's our object we want to select. Then you select the mirror line. Here, I want to select this green axis, the y-axis, but I can't at the moment because my origin is hidden. I'll just turn on my origin really quickly. And then hopefully, be able to select that green line there. That's what we want to mirror around. And then click OK. And you see, et voila, mirrored on the other side is an identical hole. Neat. Now we'll do the next radius we have. So I could create just another circle for this radius 12 thing here, and then we can join up the edges of the circles as if you like putting a string around all of them. But I can also show you the arc tool. So if we go to our arc, so type S, type arc, I will do a center point arc, because the center point should be in the same place as this hole, and it should go out, and it should go out by 12. But I'll just do some pretty rough sketch. Look something like that. Then we can go and constrain it. We'll start first with our dimension, which is D. Click on the arc itself, and then we give it a radius. So our radius here is 12. That's coming from this here. This here that says R12. So that's that radius. We can also mirror that. We could do the mirror thing a second time. Which actually, we'll do since it's just a sketch. So if I also want to mirror that in the same way as I mirrored this circle, I can just click on this. Oops, sorry. Click on that. Type S, bring up my mirror. Then I just need to select the mirror line, purple line here that we've included now, and OK. There you are. A nice mirror shape. Now, don't be deceived by it all being black as if it's constrained, because actually we still have these open points here on the end, which as you can see change, but there are ways that we can fix that. So if you take a look at our shape here, it's just got straight lines kind of between these rounded radius parts. So whenever you see things that are like that, they're like a smooth transition, that's probably a tangent constraint. So a tangent, or if a line is tangent to a curve, that means it's something like this that is showing here up in this icon, where it's kind of flat at that particular point. To demonstrate that, I'll just draw a line. So L to draw lines, remember. I'll click on that edge there, and click on... Oh, so actually that's going to make a tangent there by automatically. It's snapping to it. So I'll just make it out here so it's not by default. Press Escape, by the way, if you want to cancel drawing lines early without closing a shape, so I'll press Escape. Then we'll do a couple things. So like there, that's not a smooth transition. You see it's actually changed angle. So you can see it's like an actual turn there that's not smooth a little bit. It's a bit more pronounced if I do something like that. See? If we want to make that smooth, we can apply a constraint. So tangent, I can select it there, bring up my S menu, either is valid. Select the curve and then the line. And you see, whoop, it's gone and made it straight for us. So that's quite nice. That's what we would like to have. In fact, we'd actually like to have that exact same constraint, that same tangent constraint here. And by the way, what I just did, first time I've done it in my life, because I discovered it earlier today while I've been teaching you, so I wasn't paying attention before then. Right-click, you can repeat options up here at the top. So, and you don't have to click on it. You just have to be in the right part of the pie. So you can just right-click and then go up real fast, and you can repeat whatever the last thing you did was. So I want this line to be tangent to this circle here. So you can see that that's done. Now it looks almost constrained. The line itself is blue, but this point, recall, is still not there. So you can see when it goes across the circle, it's perfectly tangent to it, but it's not actually on the circle. So then finally, coincident constraint, our old friend. I'll do it with S. So coincident constraint, and press that there. Oops, it was already selected. Press that there, it's selected, and then press the circle, and it's connected up. Excellent, just like that. We could do mirrors, or we could just repeat the same process. I'll probably just repeat the process on this side, and then I'll mirror it onto the other side, I guess. Although we could mirror it in all directions, just depends on what you're feeling. Here I'll repeat the process so you can see it. So I'll take my line, I'll click there, I'll scroll along here. How do you smooth the line in the arc component again? Yes, that is a tangent constraint. So I'll go along and make it not smooth. So there's a pretty unsmooth line. If I want to make it smooth, I need to apply that or enforce the tangent constraint. So that is this constraint here. It looks like a circle with a line going across it. So I'll click on that one, click on the curve, click on the line, smoothed out. And then I'll do the exact same thing here. Click on the curve, click on the line, smoothed out. Just like that. Does that answer, or was that still a bit quick? Wonderful, fantastic. Okay, cool. And then of course, yep, awesome, good to know. And then of course we have our free point here. We want to make that, use coincident constraint, press S, coin. So, and then coincident with enter. Click on the point, click on the circle, sticks it together. There we are, so that's half of it done. What do we want to do now? I'll go ahead and mirror that, why not? So we can search for our mirror. And we can do our mirroring. We can select two objects this time. We want to mirror both this line and that line. And we want to mirror it across the same purple middle axis. Go ahead and click OK. There we are. There's our whole thing. Actually, has that not fully been constrained? Oh yeah, okay, so it's mirrored, so that's still fine. Still fully constrained. Then if we look at our shape here, we will have a cutout circle in the middle. In fact, I know from trial and error, because this is not the correctly drawn shape here, that this circle is going to be 26 millimeters in diameter. So I'll press my C for circle, draw something that is 26 in diameter, like that. So that's going to be a hole in this face. But this circle here does not need to be here. So if we want to get rid of these little lines here, we could have done this with an arc, like we did with these sides, and we wouldn't have had these in the first place. But since we did it with a circle, we need to trim some things. So I can press T to trim things. Remember, that's what these scissors up here are. I can trim that segment and trim that segment. And there we are. In that process, it looks like this friend over here has gotten unconstrained, because originally the circle only had one diameter constraint. Now this is disconnected. To fix that problem, because you can see it can expand out like that, which is not what we want. To fix that, we just need to reinforce our tangent constraint. So click on tangent, that line, and that should be tangent to each other. There we are, all done. Cool. I think that is the whole top profile, just about. I'll pause here real quickly. Any questions about this sketch we did there? That was a pretty funky one. The way that I've done it just now is a way I've never done it before. I've done it 3 different ways, and I've done it 3 times. Any questions about that one in particular? I'll ask in a poll in a second once we've done a little bit more, but I'll just give a pause if anyone has anything to say. Cool, okay. Well, if you're typing, feel free to continue doing so. In the meantime, I will take this and we'll extrude it. So I'll press Q for push-pull, and I'll press on this top face. We'll look at the side, so we want to bring this up a little bit. We want to bring it up 12, because that's how thick this top is. So we'll go ahead and type 12, and enter. There we are. There's our top bit. So we're getting very, very close now. Ooh, interesting. Very interesting indeed. Yeah, okay. That's a bit non-ideal the way I've designed this, but that's fine. So you can see here that there's this bit of a lip inside, where you're moving from the 26 down to the 20. Ooh, actually no. Okay, hold on. So when we extruded that? Okay. No, that's separate. So somehow this line got included here and we didn't want it to be. So that's why that looked more off than I was expecting. So this line here is our 26 that we drew. This line here is that outside bit. If we want, we can click on that and we can turn it into a construction line with X. So now it won't be a face anymore. We can also, of course, just select several faces. So if I go back actually, so now nothing has changed here. And if I do where nothing has changed, our same, well, okay, I say nothing has changed, but I've obviously changed it. Yeah, it's still a construction line, so turn off the construction line. So here's what we had a second ago. I clicked on this, I press pulled this whole thing, so you can see it's including that segment. If we want to include this donut bit as well, just click that as well, and you can extrude them together. I'll probably just do that, actually, to be honest. Then we have that. Wonderful. Okay, that looks a bit more like the correct amount of like indentation there. However, though, we know that that's probably not the right amount of indentation. So yeah, the first way I designed this I think was a bit better than what I'm up to at the moment, but that's right. We can still figure it out. So it says that's 25 away from the top. We know that this thing here is 12 thick. We can figure that out if we bring up our inspect tool with I. So press I, click on this line, it says it's 12 millimeters thick. So that needs to be 25 down. So what we can do is grab our push pull, click on that face, and we want to move that down a little bit. So I want to move that down, the difference between 25 and 12, so down 13. So minus 13. Oh, but not the whole thing there. That's a bit upsetting, isn't it? Okay, is it going to let me... of course, because that's just one face, right? If we extrude, maybe, is what we want to do. So extrude with E, grab that, then push that down by 13. Yeah, there we are. So that cuts in. So there I use the... That's another difference, I guess, Maria, between the extrude and the faces thing. The face, it moves the whole original face. The extrude just grabs this bit that's visible. There are these subtle differences that I guess you just have to come across as you get to them. Awesome. Cool, so that's pushed in the correct amount. We're basically almost entirely done. Couple of missing features. One is this thing here, which is a chamfer. So that's it's like a fillet, except it's a straight cut instead of a rounded edge. So what we can do is bring up the chamfer tool, which is either here under chamfer. Last step again, yes. So the bit where I push this in. Yeah, so for you, Isaac, this step here is kind of, if I'm being honest with you, a consequence of me like designing this part in the wrong order, essentially. Not the best of ways to do it. It'd be better if I just created a sketch on this face and pushed it down 25. But what you can do is select this little donut here that already exists. It's only, however, it's at that level, which means it's 12 down from the top. We want it to be 25 down. So we can press E for extrude, or we can click on this option up here, up on the top left, extrude, and then push that down an extra 13, and then hit enter. Does that clear things up? Hopefully. Cool. If you are still stuck there, just let me know. Awesome. But after we push down that segment, it cuts the whole thing for you. Oh, well, that's very interesting. Oh, do you mean like it's made the whole top shorter? So it's done something like, if I were to press Q and do the same thing. Oops, sorry. So not that. If I were to press Q and slide the donut with Q. You mean it's done something like, okay, yeah. So that's probably meaning that you're using press pull, which turns into an offset face operation. That's slightly different. Be sure, I guess, that you're doing an extrude, which is not actually Q, but you have to press E. It's a separate operation. That's honestly because I kind of did things in a bit of a poor order there. Does pressing E work better for you? Nice bug in my room. Oh, interesting. Okay. I think I'll show, just for the people who have to head off on time, real quick how we finish up this shape, and then I will help you more after that, because that sounds like a bit of an interesting situation. If you'd like, in the meantime, it'd be helpful if you could send a screenshot of your design or whatever, or the bit that's giving you trouble on the Discord, so I can take a look at that in a minute. Okay, cool. Real quick, for the people who have to scurry off, and I do have a feedback form to send people before they run away. But we'll add a chamfer to this edge. So you can either do that with modify chamfer, or of course our S menu, chamfer. And here in our design it says that's 3 millimeters, it's at 45 degrees, so it's by default at 45 degrees. So you can just type your 3 millimeters, enter, there you are, nice cutout around. And then also we've forgotten this fillet down here, around this edge. So for a fillet, press F, press the edge, or type 2, because it wants to be a radius of 2. R2 is given there. And there, I believe, should be our finished part. We'll real quickly check, because it's entirely possible I made a mistake in that process with our physical material. So take our aluminium, go down here, drag it over, and take a look at the mass of the body. And the mass of the body is, oh, I need to close this menu first. Right click on that, properties. Mass is 276.9, and over here we have something very different. Alright, so that means that somewhere along the line I have designed something a bit differently. So I'll have to investigate. Oh, sorry, whoops. No. It's entirely fine. 276, that's the one there. We skipped 2 exercises. That's me being silly. We're actually looking at this one here, 276. It's done correctly. If I click on this, you can see there to the side. Sorry, my bad. Got a bit confused. So we were jumped a couple. Yeah, we were designing this part. So I've got the same mass there. If I click on properties, body, same mass, 276.965, 276.965. All right, cool. So we have done that one correctly, even if we did it in a bit of a weird order. All right, real quickly, since that is technically time, I'll pass for people who have to run off immediately a feedback form. I'd love if everyone could fill this in. Obviously, it really always helps. Takes only a couple seconds to fill in. So there is that form, and I'll also put it in the Discord. That's the feedback form. Yep, if you're going to screw up now, I'd love if you could just fill that in, and that's all we need to do there. For the people who have an extra second, are there any questions that people have, aside from Isaac's question, which I'll get to in a minute? Is anyone else having any troubles or curiosities about what we've done here? I'll ask a little poll. How are people feeling about this last part? Cool. Got at least one person who's feeling alright about it. That's good. That poll's in the Discord. Any questions you have, you can type. Cool. Alright, awesome. Well, happy to help. Yep, if you have to scurry off, then have a lovely day. And I'll see you again next week for a little bit more fusion and some cool 3D printing stuff. And then after that, it's up to you guys what we do. So be sure to fill in that form that I sent at the beginning. If anyone rolled in late to that, I'm actually not sure if anyone did, but if you did, there's a link that I'll send here. That's the plans for the future one. And that will determine what we do in our second to last week. Cool. Alright, yeah, if anyone has questions, feel free to ask them. If not, I think I'll help Isaac with his current situation. Actually, Isaac, if you'd like, you could even probably, if you're feeling brave and don't mind, you could screen share what you've got going on, and I can take a look at it. If only one person can present at a time, that's fine. I can stop presenting real quickly. Whatever you prefer. I can see that you've unmuted yourself, but I can't quite hear you yet. I don't know if you've actually started speaking. Yes, could I share it for further sketch? Yes, yeah, so I will be sharing all of these documents. I'll be writing up later today another post for the website, and I'll link that in the Discord channel. That will have all of these practice exercises and more, even the ones that we didn't get to, as well as some other materials that I found, links to tutorials and stuff. So yes, worry not, there should be plenty of practice.
Hello?
Hello, I can hear you now, Isaac.
Got it.
Wonderful.
I'm just going to look at the screen cap.
Okay, cool. I'll toss on headphones so you don't have any echo. Right. Cool. Yeah, yeah, the screen share is like a presenting thing. I think you should be able to. I'll stop presenting in case that runs into issues for you. And also pause our recording. OBS.